Hello, 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 hello. It has been a while on this Astro Guy account. That's crazy. S- So, I got called out. Was a bit stupid. Um, also disclaimer: I am stupid, so don't trust anything I say. Take everything I do with a grain of salt. Let's begin. We're just gonna go through this PowerPoint, and I'm gonna try and do some questions. Yeah. So let's get started before I knock everything I own onto the ground. Thrust configurations, thrust generation, thrust equations, and basic engine performance parameters. This is just basic thermodynamic stuff, I believe. Or propulsion stuff, rather than thermodynamics. Gonna bring out my calculator and everything. Alright, let's get started. Time for thrust configurations, turbojet. So this has an air intake, a compressor, into the combustion chamber, I think. And then there's turbines, and that's the exhaust. Same thing, but there's a fan instead of just a normal air inlet. Turbo shaft, I haven't really studied, but I see a propeller at the here. So, yeah, we have a turboprop, which is a prop instead of a fan. Turbofan, high by, oh, I didn't realize there were low and high bypass. High bypass has more air intake, which means that the Mach number is lower. The Mach number is lower at 0.5 Mach number. This one has a 0. No, it's greater than 1, I think. 1 to 1.5, something like that. Let me check my notes. I'm sure I wrote this down. Low bypass is low, less than Mach number 2. High bypass is 1 to 1.5. Turboprop is 0.5, I believe, yep. And ramjets are Mach number that is greater than or equal than 2.5. They are usually secondary. So ramjets have an air inlet diffuser here to a flame holder. This is the combustion zone, and there's the nozzle. Going on. As I said, inlet compressor combustion chamber turbine nozzle. I didn't actually think that we would be going over this again, but we are. So let's just read through it. Air inlet intake compression, combustion chambers, turbine. I'm not sure if it's turbines or turbines. I heard some guy say turbine. That stuck in my head. With exhaust. Compressor air inlet. Compressor combustion chamber. What am I reading? Only efficient at high vehicle speed. That's cool. Jet noise. High exhaust velocity. Yes, most. Wait, what? Turbojet. I think turbo fans are most commonly used in aircraft nowadays. Commercial aircraft. We're just gonna go over this quickly. Air inlet, fan, compressor, combustion chamber, turbine, turbine and nozzle, 2 stream. Okay, this is interesting. One through the core section and the other through the fan section. Okay, so there's air going through this direction, and there's also air going in here. And the other through the fan section, both designed to generate excess momentum on the exiting sides. Don't really understand what that means. The averaging is also, wait, it's not like we need information for the exam. Let's get to understand how it's going to be used. Yeah. Sorry, I was just checking my setting. The average exhaust velocity is considerably lower than turbojet. Yeah, okay. Means less thrust. Significantly quieter than turbojet. Okay. Rolls-Royce Trent 900 turbofan engine used Airbus A380 family aircraft, the most efficient engine in the range of speed. There we go. That's what we're looking for. I want to say 1.65, 1.4, somewhere around that Mach number to 1,000 kilometers per hour. Wait, kilometers per hour? Yeah, I have no clue then. No inlet, just the exit. Crazy stuff right there. We haven't I haven't learned much about rockets. Okay, let's see. No inlet at rockets. Let me write this stuff down. Let's see, what is this? This is thrust principles. That's chapter 2. For me, anyways. Chapter 2. Thrust principles to thrust configuration. Rocket. There is no inlet, just the exit. Rocket engine exhaust is formed entirely from propellant carried within the rocket for use. That makes sense. High enthalpy created. Enthalpy is something to do with heat. Engine heat, energy, something like that. Let's see, enthalpy, the amount of heat content used or released in a system at constant pressure. So, amount of heat energy used or released. It's not change in heat energy, it's used energy. Okay. High enthalpy created in the combustion chamber and converted into kinetic energy with a nozzle. Rocket engines push rockets forward by expelling the exhaust in the opposite direction at high speed. Yep, makes complete sense. My room is cold and hot at the same time, which is nice. So first we have the igniter, that's the ignition. Go through ignition into, well, propellant grain, thrust, mass flow, sustained pressure. Propellant grain. I'm not too sure. Really explain what's happening. Propellant grain. I wonder what that is. Propellant grain. Solid fuel or propellants are used in forms called grains. A grain is any individual particle of fuel propellant regardless of size and shape. The shape and size of grain determines the burn time of gas. Solid fuel propellants. Oh, so this is solid fuel. Okay. So ignition into the propellant grain. But it is solid fuel / propellant, which goes into throat. Diverging nozzle. Converging nozzle. Doesn't that increase the pressure? Which that reduce velocity. Am I stupid? They will talk about it somewhere, I believe. Thrust equation. I'm not looking forward to this. I can't understand how a freaking rocket engine works. Like this in simple terms. Converging nozzle effects on pressure. In convergent nozzles, there's an increase in velocity and decrease in pressure. What? The heck? Convergent nozzle. But doesn't it like cap out at Mach 1? Why pressure in nozzle is decreased? What is reason? Mechanical engineering. Because velocity increases and total energy must remain constant. Subsonic nozzle, P decreases, velocity increases. Pressure decreases here? I mean, I guess it's exiting, if that's what it meant. But I would assume that there's more pressure buildup in these areas. No, I guess yeah. Pressure decreases in the supersonic nozzle. Velocity increases. Oh, this is for different Mach numbers, of course. So in Mach greater than 1, the pressure decreases, velocity increases in a nozzle. I don't understand. Velocity increases to maintain conservation of mass. If the flow is incompressible, compressible flows are Mach that is less than 0.3. The cross-section decreases. The velocity must increase to get the same mass through the... Ah, right, of course. I'm just an idiot. Okay, next. Oh, I need to write this down. Into the throat. And then nozzle, or just what did I write before? I wrote exhaust. That is no inlet. I wrote that already. Principle of thrust, conservation of momentum. Theory suggests that the inlets and exits at high speed through the nozzle exit, thus creating a momentum. Wait, what? That's not for rockets. Oh, I'm just reading this here. It's not technically accurate, but it helped me conceptualize it. Think of pressure as force the fluid exerts outward on the pipe. The faster it moves, the less energy it has to push outward, and vice versa. For supersonic flow, why does velocity increase with an expanding nozzle? That's counter to our intuition, which only has experience with supersonic flow. Think of the fluid molecules as a crowd of people trying to get through a narrow tunnel. When the tunnel is tight, they all cram together under a lot of pressure. As the tunnel gets wider, they can go faster. That's how subsonic flow works. The difference is the speed at which information about the surroundings is communicated from molecule to molecule. Subsonic flow, the information about the narrowing nozzle gets passed backward from molecule to molecule, and they are able to align themselves in an orderly fashion and accelerate through a converging nozzle. That's really cool. I see. That is really smart. Okay. Great explanation from that guy. Alright, let's continue. That was a wonderful explanation. It's all about the micro. Yeah, the micro. I'll look at the molecular level. Error suggested the exits at high speed through the other exit, creating a momentum increase. Wonderful. Time rate of change of momentum inside a control volume is equal to net rate of influx of momentum in control volume. So mass flow rate for the inlet and the velocity of the inlet, net rate of influx of momentum in control volume. What is this describing? This part is describing, let's see, its mass is kg meters per second. Oh wait, it's over time, isn't it? Kg mass flow rate unit kilograms per second. Okay, so it's kilograms meters per second squared. So is that momentum? Look, I'm stupid. That shouldn't be momentum. The mass flow rate and velocity in, less flow rate, velocity out. That would be how much get rid of influx of momentum. The change in influx stand for influx mean rather. The fact of a large number of people or things arriving at the same time. So the change of total change of what I'm saying, momentum. The system total change of momentum is, yeah, okay, now that makes sense. Net force is acting on the control volume. So we have, it's not stagnation pressure, that's pressure, force plus pressure, oh wait, outlet pressure minus the heck is E? Oh, P, O, P, E, and A, E are the ambient pressure, exit pressure, and exit area. Oh, so ambient pressure and stagnation pressure is different. Ambient is surrounding pressure. Stagnation is, let me find it different. I don't want to explain so it's wrong. Ambient and stagnation pressure. What's the difference between ambient pressure and this is from Quora, the first link I clicked. No, this is asking static, ambient, and velocity. Stagnation versus static. Well, I can assume that static and ambient is the thing. What is ambient pressure? Ambient pressure is on an object, pressure of the surrounding medium. Okay, that's from Wikipedia. Is ambient pressure the same as atmospheric pressure? Ambient pressure is the atmospheric pressure of a given location. Okay, what is the difference? I can't type. Between atmospheric pressure and stagnation pressure. Stagnation versus static. Static is same. Oh, damn. Let me just find what is stagnation pressure. I did search it up a long time ago, I don't remember. Stagnation pressure is the pressure the fluid would obtain if brought to rest without loss of mechanical energy. Pressure the fluid would obtain. The pressure of a fluid when at rest. That sounds about right. Okay. So most likely we'll be using this for equations on, what are they called? Propellants. In propellants? Yes. Anyhow, we have the exit pressure, the ambient pressure, so the atmospheric pressure I'm just going to say, and the exit area. That's how the cross-sectional area of a nozzle. Alright, moving on. Do I need to take any notes? Let me check my formula. I don't think. Let me check my formula book. Not a single viewer. Nuts, God. Not like I expected. suppose thrust change. I don't think I'll be needing this. So yeah. But I'm just not gonna care. This thing probably isn't too required. First equation for the steady state propulsive system. Steady state. Steady state drives. So they don't. I think it needs moving parts like no fuel, solid propellant grains. Yeah, so yeah. First equation for the steady state propulsive system. And that's the equation we need. It's crazy. That's F, guys. Whoa. Alright, nice flow rate is the inlet. Second, sorry. Alright, back to this. Mass flow outlet is what the heck am I on about? M subscript 0 is the inlet mass flow rate. What? Oh, MO is initial mass flow rate, is the inlet mass flow rate. Mass. Okay. Outlet mass flow rate out equals to MO plus MF. MF is probably M final. Mass flow rate final equals to, oh, my brain. This is driving me nuts. I'm sorry, I'm typing stuff. Alright, I'm back for real. Outlet mass flow rate 1 plus F. This F is not this F. F equals to the fuel air ratio. This probably is important. I'm not gonna write anything down because all in my head, don't worry about it. Honestly, I'm allowed 2 sheets of notes, but I just don't know what to put into the notes. Like, I don't see anything I really. Probably just counting 2 questions. Outlet mass flow and out. I know I've said this like 7 times, but it's not getting into my head. Okay, so M out equals to MO. MO is initial. I see. Okay. Okay, so initial mass flow rate plus initial mass flow rate times the fuel air ratio. This is equals to MO times MF, or times F. I was right here. Yes, okay. To obtain larger thrust either by increasing the exhaust velocity with respect to incoming velocity or by increasing mass flow rate. That's self-explanatory. Or both. Or both. Turbofan. The momentum differences to be considered for different streams. That's thrust equation. Turbofan. Where's turbojet? There's no turbojet. Oh, there's. Okay, let's see. Turbofan. Momentum differences need to be considered for different streams. F equals 2 mass flow rate. I don't know what C is. Oh, there's mass flow rate of air through the core part of the engine. This is really annoying. Okay, this is what I do need to mark down what all of these words mean. Letters. I have a special sheet for that. I'm going to go back to the top and write down. Actually, that wasn't. Okay. We have M in. We have M in. Actually, I know what M in is, but might as well. We have U in. Oh, I just put a dot onto. We have M dot out. Let's have two tables. Out. F is source. O, that's a good one. Ambient pressure. Let me write that. My goodness, I'm a mess. Ambient pressure. We have mass flow inlet. Mass. Wait, that's not mass. That's velocity inlet. Velocity of inlet. Velocity at inlet. Mass flow out. Nice. And velocity at outlet. We have E, that's pressure at exit, or exit pressure. We have velocity AE, which is area. Boom. Moving on, we have mass flow rate, inlet mass flow rate, outlet mass flow rate, from F is fuel air. I think that's in the book. Man, I can't talk. It's in the equation sheet. F 1 plus F F. Should be. There's no way you don't have fuel air ratio. There it is. F is triple equal sign. I don't know what it's called. Mass flow rate final over mass flow rate core. What? I don't get why there's always a discrepancy between the formula books and the presentations. It screws me over, man. It screws me over. Well, aside from this, I'm a bit disappointed in myself. Not able to get an internship. I know I'm a bit stupid. Yeah. Want some experience, to be honest. Anyhow, I guess I'll have to write this part down. F is the airflow ratio. I'm gonna write down the formula as well. Mass flow rate divided by mass flow rate. Initial mass. I assume that's a 0. There's no way it's an O. Right? Right. No, that looks like an O. This is what I assume 0. Can I find a 0 somewhere? Or an MO? Maybe it represents the core as well. I do not have the clue. Subscripts will throw you off greatly. This is air fuel air ratio, sorry. Mass flow rate at the core. Don't like to throw us now, we read that. We're here now. See? Slow rate of air. Of air. I should probably add of air through the core. Parts of the engine. That's for turbo, and I shall make a marking for that. Turbo fan. M fan. Mass flow rate of fan. Because is mass flow rate air through fan section. Wait, these are for, aren't they? Inlet mass flow rate. Yeah. Is it? No, inlet is still air. Air. Outlet mass flow rate. It's the exhaust flow rate. To obtain. Why do I keep go back here? EEC. That's for exhaust velocity. Let's have a look at the turbofan. 4 is here. So the whole thing is a exit velocity. There. At the core. Fan exit. Yeah, fan exit velocity sounds like it's here. 4 sounds like it's here. So. Brain. Astro guy. Brains. Oh, you don't have. Lazy. And there's a comma here. There's a comma here. I see. That's why there's an M comma. Mass flow rate at the core. What does V? What does V stand for? I thought it was control volume first, but it's not. Might be volume. Mass at the core volume. That makes sense. So. Sorry, I'm talking about one of the questions I saw early on. Core exhaust velocity. And exhaust velocity. So, my mother, asked me to apply for a job outside of the space sector. Now, I'm sure that's good work experience, but I really want something that's engineering related. I'm not too sure. I would much rather work at something to do with engineering so I can learn from the industry, and I can take those skills into my coursework next year. Integrated master's degree, which means that it would be useful if I just do work experience. Yeah, I'll be earning a bit of money, but all in all, I feel like it's more of a waste of time when I should actually be relaxing rather than working my butt off for a bit of cash that won't will be short term, but not really the long run. Whereas if I get an internship in the space sector, that'd be much more useful. Anyhow, rocket. There is no instant momentum. Thrust is provided by combustion of propellant. Okay, first let's analyze this turbofan force momentum difference. Ah, I see. Different streams means the core and well, the outer area fans. That's the core mass flow rate at the mass flow rate of the air at the core through the core. Read that. Core multiply 1 plus F multiplied square bracket multiplied by UE. That's core exhaust velocity minus, I assume it's initial. Ambient. It's ambient, isn't it? It's ambient. Yes, that's ambient velocity. Yeah, we got ambient pressure here. Okay, we work that out. Fuel air ratio is final. What's MF? What is MF? This is ambient. This has to be final, right? Right, me? Right brain? I will assume case. That should be active. Don't know. This doesn't explain. You know what? I don't need this knowledge. No worries. So many subscripts. So many. Okay, moving on. Have a rocket. I wrote this page out of my notebook thinking, yeah, but I keep writing on the side of it, which makes my handwriting look even worse than it already is. MP mass flow rate balance. I'm gonna have to link these by exam like to numbers, I think. I don't know if that makes any sense, but some equations like m mass flow rate 1, I have to link like m inlet to m1 or something. Equations. Hopefully not. Hopefully the exam is really easy. I've already passed this module, but I really, really want to get a first. So yeah, that's my goal right now. I'm moving the flat. Yeah. I actually don't think there's any rocket stuff in this exam. Now that I think about it. Oh, no, there's no. Okay. Mass flow rate of propellant multiplied by the velocity at exhaust. Okay, let's go back to the turbofan. Which things have F in them? Fan. They use fan to denote that. Anything else? Maybe the turbojet? F in their name? No. The rocket flow of exhaust? No. I don't know what M.F is. What is mass flow rate? Uh, Subscript. Let's try that. Alright. NASA, come on, show me the way. Nope. I don't know. See. Point that my mother just said. Humans need different experiences in life. Plus, we don't always get the luxury to get what we want. That's normal. That's very true. Uh, just because I'm a top student doesn't mean I'll get the chance to get into a good job in the space sector. Which is why I'm trying to get work experience. But yeah, my mother's probably right. I should work, do something. Well, my father also said that I should do something outside of engineering. It's just that I've had a taste of engineering and it's fun. Fun. Like I joined academy for 1 week, 5 days rather, for a concurrent engineering design workshop, a challenge rather. And as a group of 30 people, we worked together. Yeah, made a spaceship. No, not a spaceship. Satellite. Which acted as a mothership. That's why I said spaceship. Um. Anyhow, it was one of my more fun experiences. So I am glad I did that. Learned a lot from that place. Let's just keep going. Let's keep the grind going. On the rocket, let's do specific thrust. The thrust for a given launch flow rate. Probably write this down. Specific. Thrust. S. Rate. Engine. I even make this. Why am I getting side? 7 months. First on stream. Track record. Stream. 7 months ago. I started. Yeah. New academic. Specific thrust is FS. Okay. That's going on my notebook. FS. Oh, still don't know what MO is. Wait, no, it's ambient mass flow rate. Doesn't sound right, does it? Just for a given mass flow entering the engine. Does it make sense? Ambient? Kind of. It's so hard to understand because there's O's, there's out, in. You know, which one's which? Mind. I keep zipping up because oh, if you can hear it through the rest. They give it less weight. Resting. There's time to about 5 days. No, 4 days. Okay. I might finish switch principle and basic analysis of gas turbine engine rates. Yeah, let's see how that goes. Turbojet engines, negative pressure thrust. Turbofan engine assuming fuel air ratio less than 1 and negligible. Negligible pressure thrust. Honestly, AI might be able to help me there. Engine, what exactly is the pressure thrust? I'm teaching power plants on ATL. Honestly, have some trouble wrapping my head around this one. Most literature describes the term pressure thrust opposed to momentum thrust, saying that during high thrust conditions, the choking exhaust gas reaches down cannot be over, and thus the static pressure of the gas beyond atmospheric pressure. Pressure thrust is added to the momentum thrust to make up thrust. Firstly, it is well known that exhaust gas velocity of aircraft go supersonic. IJ, for example, why is this restriction in turbofan engine? Well, I know the answer for that. Of the not, it's not. Turbofan engines can which one? Mark one. Turbofans can reach guys on. Secondly, it is often emphasized in training material that you should avoid thinking of thrust as acting on or pushing on the ambient air behind the engine. I was thinking more. Isn't that exactly what pressure thrust is? And by pressure times the area that. Indeed, exhaust gases can be expanded beyond Mach 1, and doing so will result in high thrust from high propulsion efficiency. Problem is that pressurized gas expand. Blah 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 blah. Doesn't explain what I wanted. AI time, let's go. See what Aria can help us with. Negligible pressure thrust refers to a situation where the force generated by pressure acting on a system or component is so small that it can be considered insignificant. Honestly, I wanted pressure thrust. I think that's yeah. I'm just an idiot. Okay, let's keep going. Um, Pressure thrust is a force created by pressure acting on a system or component. In case of turbine engines, the nozzle is designed to exit pressure, ambient pressure. Ooh. How do I note that down? How do I note this down? Fabulous. Turbo. I was in turbo. Fine. Turbine engine. How's a turbine engine? So turbo fan. Yeah. Turbo fan, turbo jet. Oh. Okay. Oh, I see. So these turbojet engines, turbofan engines have negligible pressure thrust because they mimic the ambient pressure. It also is designed to make the exit pressure equal to ambient pressure, thereby causing the pressure thrust. Design helps optimize the efficiency and performance of the engine. It's important to note that engines work on the principle of momentum change and pressure difference. Is that right? Does that sound right to me? Momentum change. Yeah, okay, sure. All the pressure thrust is a factor in engine operation. Certain conditions, such as during takeoff, the momentum drag of the airflow through the engine, negligible forces allowing the gross thrust. There. That is gross. To be considered equal to net thrust, submarine negligible pressure thrust means that the force generated by pressure. This is the same thing as the introduction I gave. Yeah, okay. I'm done. Understand this. Oh, there's a new term here. Let me write down that MO may stand for ambient mass flow rate and mimics pressure. Oh, that's pressure. I'm stupid. Write down the for turbine engines mimic pressure. Shoot, ambient pressure. Oh, pressure. I'm being stupid right now. Just thrust. Oh, it's also is designed to exit pressure. Okay, so PE. Well, turbine engines mimic the O. Hence, negligible next up. We have thrust-specific fuel consumption. F and S next, kind of. So it's SFC, defined as the fuel consumption normalized thrust to be produced. Oh, I couldn't click off this one. PSFC equals to mass flow rate F. Do I have MF? No. I'm just gonna say mass flow rate final over the force thrust. SFC down thrust direction thrust specific I just realized it's probably sign. That's not the full questions we're going to be doing later. Yep, it's right there. First specific fuel. Unrequired, but maybe minus the fuel consumption. Normalized. Why is it spelled with a Z? Is that how it's spelled? That's 2 SFC flow rate. Right. So why did I write the formula now? Just said it was in my formula sheet. I have to check it again. Second formula. In the mass flow rate of the fuel. Mass flow rate of the fuel. Oh my god. MF is mass flow rate. I believe. I cannot write today. That makes quite more sense. Yeah, fuel air ratio is the mass flow rate over the ambient mass flow rate. That makes a lot of sense. Yep, okay. Good job, me. Good job. More efficient engines with higher thermal efficiency. More efficient engines. Yeah, this is the reason. Our professor did not teach us any of the subscripts. Just read the equation and read the paragraphs. Done. Right now, I'm trying to go through the PowerPoint by myself, understand exactly what he's teaching, which is probably what everyone else is doing. There's like 10 people who attend his lectures, like 80 aerospace students. 80 people attend his lectures, I believe. Sorry, 10 people attend his lectures, and none of us get it. He doesn't teach at all. And I probably shouldn't complain on a social platform, but that's the truth. I don't enjoy his teaching style. We ask questions, he just tells us to look at the PowerPoint again, understand it, which is fair enough, which is what I'm doing right now. But if he keeps telling us to ask questions, at one point I just kind of I went, and I didn't really understand. I said, "Oh, okay, yeah, I get it," because I couldn't be bothered to learn from him. I understand anyways. Plus, I should just keep prodding, but yeah, I didn't want to waste my time there. Stuff might come up. It'll be on low speed aerodynamics and some proposed questions. Anyhow, let's continue. More efficient engine with higher I'm not even in the meat of this topic. I should really. Yeah, but I like to understand the topic before questions. So a low TSFC, high yield fuels with large enthalpy, yeah, pressure. Why would the gas constant? Not gas constant. Instant. The heck is PR? It's really hard to know what you do. Maybe it's better to just go through the questions. I like to understand things. Oh, I like this song. Different types of jet fuel. Plus the same heat. I'm trying to think of what enthalpy. Large change, increase. Good, right? Means more stuff is exiting system. HP. Got the wrong thing. I need my equation sheet. HPR. Does this HPR? HPR does. Okay, so depends on the thermal efficiency one, and also okay. So mass flow rate of the fuel multiplied by HPR is the rate. Should yeah, actually is HPR. It's really frustrating. Oh, no, that's just one red. More efficient engine with higher thermal consumption. Fuel large, say large enthalpy. However, for most engines use. Okay, so this HPR value change too often, and it's going to be a set value anyway, which we'll get likely in the question if it's given. Highest specific thrust jets come at the price of higher fuel consumption. Higher specific. I'm sorry, nothing's going to my head right now. HPR. Highest thrust is the thrust for a given. And the price of a higher fuel consumption. Somewhere here, no MF. Okay, so it's relation. Some relations aren't. Overcome higher instant limit at high. Song is really. And adjust my song. Oh, back screen. Shoot. Okay, whatever. SFC. Low speed of sound. At higher alt. Have the effect of reducing Mach number. That's understandable. IS8. Power output is taking into account the fact that carries Genes. That value is small. Mass flow rate, ambient mass flow rate. Ratio velocity at sit. I believe this is a square. Yeah, my professor likes scripts. Stop. And stagnation pressure, which, we understand it, learned about it, but other people input. Question, pretty. Oh, heat of combustion. I would like to make unit. Chimneys. No, no, la 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 la. And HPR. Have I missed it? Yeah, I saw energy efficient. Yeah, no, that's not gonna have combustion. And slightly. How long have I been going? 7 minutes. Joules per kilogram. Joules per kilogram. Or whatever the heck it is. And that's imperial unit. Maybe a bad idea in the future, but so be it. I only use SI. Well, I sometimes have to use inches and feet. I'm not too comfortable with those ones. People like measure height in inches. It's very difficult for me because I'm a bit stupid. Engineer who can't wrap his head around units. Yeah, he's going far in life, isn't he? Well, actually, I'm not an engineer yet, guys. Let's keep going. Propulsion power of the engine is defined as propulsion power. FU. Oh. PT. Propulsion power of the engine. Interesting. Why is it T? It's just a random letter thrown in as a subscript. Doesn't even matter. Power thrust, I guess. Power propulsion. Power thrust. Propulsion power. Power thrust. Question mark. Is this question in the formula mode? T. PowerPoint, guys. PowerPoint. Probably is somewhere. FUO is. Nope, it's not. Which means I should probably write this down. Yep, I shall write this down. E T equal to F O. Then put that in blue square brackets. Accelerated in red. Like the genius I am. U0 is flight speed. And flight speed. Velocity. 0 light. Yeah, people outside my window. My window. Not my window, my handle of my. And you develop thrust F. That's fine. F is fine. F is always fine as a subscript. Thermal efficiency. I know. I want to say it's near. Yeah. Imbecile. Ether T. I do. No, this is actually my. Don't need to write this down. No, not near. Near is that guy in Jiggy. No, that's the right thing. No. Because the effectiveness of the engine will excess. G. This does. Oh, you guys. What? Thermal efficiency. I typed it wrong. It should be high thermal. Thermal efficiency is a measure of how well a device converts thermal energy into mechanical work. In general, high thermal efficiency is good of the energy converted other as heat. Ah, okay, so it's more of the most of high thermal efficiency are considered efficient. Okay, cool. Engine power output. That is in terms of velocity and light speed. Okay, I is good. Propulsion efficiency. L. I is good. L. Overall efficiency. Like that. Ow, I hit my leg. On. Propulsion efficiency. Propulsion efficiency. Jet engine. Oh, I'm tired from just went to a whole hour. Actually understanding it at my own pace. Rather than speeding through it in like 1 hour. Exactly 1 hour. Times an hour and a half when try and ask questions. Efficiency for turbocharged engine to P over to P max 1 at approximately tends to as choice of determine optimum flight speed regime. The aircraft that is the speed lower than the engine with adjustment brightness. That is if the desired cruise low, then an engine of choice. Now I'm not good at aircraft. Space student. Astronaut. So yeah. Anyway, propulsion efficiency. Um, not in here, so we have my notes about Uh, is big P is propulsion. So if we look back, we have HPR, that's of propulsion over R's. I have to work this out slowly. Get there someday. So big O on have those brackets. I just did the worst curly X tends to one. I'm gonna write one as n option 10. U0 ambient pressure flight speed velocity velocity exhaust somewhere. The same thing as accident. Choice of the exhaust. Ah, oh, shoot. I'm weak. I'm sorry. I'm weak. I wasn't talking. Oh, we're done. I wasn't talking. I would be using a lot less energy. Not used to talking. I do want to learn how to talk, become more social. So I'm using this as an opportunity myself. And talking makes me want to ingest more liquids, which is something I need to work on. Actually, so let's carry on. We understand these. We understand everything. Ah, yeah, good. Now I will back screen and pull up the questions. Have them print out as book questions. Now this is not topic. No? Well, we have to find the answer. And actually, axes. Let's do the questions. Topic. Rushed. I didn't turn on the right thing. Opera research. I turned on my window capture. I lost source. Can I read screen? I just did whatever. Doesn't matter. The low speed. I don't understand. I want to find the sheet. Formula sheet. Go. I will change the cap. Uh, Profit? Profits. Has to be nice. Okay. Now to read the question. For a turbojet engine scuffed turbojet engine air mass flow rate option 1 we know mass flow rate air mass flow light speed jet F G turbojet 1 jet engine F 1 F 101 6. Now, we know that f equals a. So we know that this is newtons per Newton. Divide that by 1,000, so 4. But the answer back to the question 1 on yes. The answer is shown. I am trying not to question. Question 2 should be much easier. Late. At F again. 98.5b. A fan engine used going. Find something. Thought that's how it's gonna be. So a fan engine cluster. Very long one. And fan question. The fan engine using machines. MO. What do we know? MO. Break down as light. That's MO. Mark number. Oh, that's slow. John me. Initial mark number. No, that mark number spelled with a capital M. Well, from all my research, all I saw was capital M. I don't know. At find this one. Found find that the alternative R is alpha. Alpha? Huh? Alpha is angle of attack. Now this is the issue with so little constants. When there's so many subscripts. I understand that. But like alpha angle of attack, guys. Why is it equal to R? Don't know what it means because I've never learned it. job. I'll put it down there. Ratio. Probably going to my of M0 ambient, I guess. Shouldn't really. Last time I did, I got the fan exhaust estimate as 4 and can be estimated F is engines. F is down in our notes. What I did MC N plus F. F is 10. How we do it? I wonder. Less than and this equation we have NO. I'm looking at the notes I should probably has nothing about alpha. That must mean a specific MF brain is just not actually alpha is the bypass ratio. M so if we use this, multiply it by its value that we we have Mach number, so find the new genius guys. Don't have his and cheating. Right. Okay, I believe assuming assuming pressure, assuming F actually small. Pressure for pressure forces. I'm so sorry. I should have read that. Small pressure force means first part of the equation only. Technical. I don't know. I think Simon can at one. Okay, from this question we know that we took. What is M's flow rate at the MO? Why do we need the MC? Okay, I get it. I get it now. That's not the point. Bottom. Oh, we don't have. We have East and we don't have and. Alpha. That's perfect. Get you over now. This question. Should probably like destroy like adding what each of these wide in engineering. Wow, crazy. Um, and I'm only on the second, and I'm still short. So see how this is. Write down the whole equation because that's what you should do. And manipulation. About algebraic manipulation. Not much that has to be done. It's just thinking about the steps in your head. That gets so proud of working on this question. I'm pretty happy about it. Yeah. You don't know? Of course, not me. Not doing it with me. But whenever someone difficult question, it always makes me smile. Like you see that thought process, and you're like, "Oh my goodness, it's genius!" Unlike me, why am I berating myself? Okay, I'm right down. See, okay, it sucks that I can't stream as well. My thought process. So, know that mark number to yes, 0 over a0. Right, isn't telling us the old. Yeah, we know the temperature, so that way doesn't matter. We just find it out. Mark number. So u0 equals m0 times a0. 0 equals 8, 3, 6, 6. Mark, yep, ms 2.83 multiplied by 6.246.178 second. I'm gonna use the whole thing down minus 200 and I'm just checking my value. Question. Let me check if that's meters per second. That is meters per second. And then have what is alpha? Has duration plus 8 over 1 plus 4 divided by 10. That's a 5. 7 meters per second. So my units are meters. Check, check. Yep. So on this for myself, fs equals just 1/7. Not my style. I'm just gonna do it. Type it out. Brain is getting tired of trying to work at the same time. So this will help me become a teacher if I decide to wrestle one day. High chance. Now, don't forget this question is done, and I also wrote M as a big M, 5 dot. No, that's recurrent, not. I just like saying dot dot dot. That thing starts with an E. Every time someone like asks, I just remember it starts. My brain says ellipsis. Now I have to check. Not spell, but I don't know. On to next. Force is equal to 0.8 dot multiplied by m dot multiplied by 1377.6 kilosecond. That's 2. I'm a bit confused. FS is only in mass in second? Specific thrust is only in meters per second, is that correct? Specific thrust. Second, isn't it? They bring on the big guns. AI. 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 It's Newton per kilogram. It's Newton per kilogram. Unless bypass ratio is supposed to have units, I don't see how that's possible. Nope, that's not. 1 over 1 plus alpha multiplied by UEC minus UZ. That's meters per second. Like, why? Like, why? No. Let's say that 1 plus alpha was equal to bypass ratio. What is alpha? But I don't know. Okay, let's alpha bypass ratio. Mass flow rate. Wait, what? Mass flow rate over mass flow rate is per unit, which is super annoying because that just makes it FS equals. Wait a minute. This makes sense, doesn't it? So ChatGPT is wrong. It wasn't ChatGPT. Aria. Aria was wrong. This thrust. Just use well, it's not dimensional analysis because units, but unit analysis, little analysis. So we have F equals kilograms second squared divided by kilograms meters. Sorry, flash flow rate in kilograms per second. Mass flow rate unit. Kilograms per second. Kilograms per second. Which means that G and kg are cancelled. M S negative 2 minus 1 is ms. Okay, it is meters per second. Why? Why is wrong, bro? Why is wrong? I don't know why I thought it was calculate. Yep. 137.5. That would be ins. No, not. Oh shoot. No. Yeah. Okay. A second. Kilograms. Oh jeez. Second. 5 second. There we go. Brain's working. There we go. Which gives kilograms grams per squared. Three. No. 0.7. The answer? 74 kilonewton. That is absolutely correct. We smashed it, boys. Oh, let's go. Have a look at this. F equals MC 1 plus F. Huh? What? Did they just sub? Did they? F is selected. I see. Actually, sheet. Oh, I did it. Oh, they just. Oh, they just. They did was they just used correctly. Uh, alphas. I don't know how they came. I used the formula, so I just took it afterwards. I'm a genius. I'm a genius. What can I say? Yeah, they got 73. Oh, so she. Oh, she's bad. We're going really slowly. It's been almost 2 hours. Two. We don't need your. What? We don't need your tip. It will leave. I'll get a tip. I'll just look at a tip. Good. Question 3. Calculate thrust. Thrust of a at burn rate of 1083 pounds of oxygen. LH2. Oh god, chemistry? They like didn't teach that. I kind of think it was them. I They didn't teach anything about chemistry. That leads issues. Wait a minute, it's just issues. It's fine. No, it's because it goes into moles and grams per. I've never worked with C, except for carbon copy. CC. Don't know enough about liquids. CC's and volume. No. 1 cc natural. 100 cc. Yeah, it's volume. I don't know how to convert heat. Sucks. And gallons per second? Who are these guys? Let's just have a 20. I really, I'm gonna. As I said, I believe that he's. I or I'm gonna skip. I probably should. Should how do you expect me to do? I find Thursday and have this S yeah, I don't want to look in the chats. I think what can work with time F S pressure exit pressure pressure minus now. What do I have? Have mixture ratio. Find area from that. Gonna work from burn rate. Burn rate. Is that question C or something? That's ME. Yeah, I'm gonna look. I don't see a ever on. Yep. rockets a parametrical equivalent exhaust velocities you often use, which combines the effect of jet momentum and pressure thrust in equation. Now, where was I going to find this information? I have no clue. I have no clue. Q. We didn't even look at this in the presentation. Disgusting. Where do you expect us to bring this knowledge out from? Don't teach this to us. Nope, it is not in the formula either. I have inkling this will not be in the exam. Let's do it anyway. It also says, let us consider the thrust of the Space Shuttle main engine SSME. And then for SSME, EQ is to 14,520 feet per second. How on earth am I going to bring that out in the exam? What? What logic is it? Can't do it without the tip. I'm going to use the tip now, and maybe there will be a question exam, and it gives you all the information. I need to not get questions because it's showing on my screen. Back to the equations. Get the tip now. Rockets parenthetical, which combines the effect of jet momentum, pressure thrust equation. Q is AE divided by. Wait, this is. And my pen is running. Flow rate of the balance. SSM. I think feet per second is. I see the S after the feet. Yeah, let's go. UE. Feet of U. Who we have? No, I can't do it. Burn rate. Burn gallons. Grams per arc. All I can say. Gallons can be converted into C, right? Is that the correlation they want us to see? Gallons is liter, CC is volume as well. That's the only link I see in equations. And I don't know, we're going to use mixture ratio. So honestly, I need to practice this. And I need to see the solution first. So let's move on to the solution. Oh. Yeah. I just need to think deeper. That's the equation sheet. That's the equation sheet. Basically, I'm an idiot. So we know the F goes to M plus AE. Okay. So the top half of the equation, Q. Okay. So we manipulate UEQ, multiply it by mass flow rate of the propellant, that's equals to UE plus P minus P0 times AE, and you substitute that formula F to MP, blah blah blah, MP times MP times U, and then MP squared, F equals to MP squared times UE. That simplifies the equation by a lot. What can I think of the next step by myself without cheating? It's the main question. Wait a minute. Something looks wrong. Something is definitely wrong. Yep, something is wrong, something is wrong. Let me think. Yes, there is something terribly wrong with what I just did. Don't just substitute equations like that. Which means we're back at square 1.5. Okay, I'm gonna do this silently. I can think. I'll think out loud. Screw it. Let's write in the rocket equation again. F equals M plus P minus PO in a bracket thing. So what I'm going to do instead is I'm going to manipulate it to get Q times MP. Right, yep. Minus UE is equals to minus PAE. And I can just sub that in. Yep. This will make sense. Yeah, F equals MP UE plus Q MP. Wait a minute, what? Ah, right. Minus UE. Now, what this means is nothing. Nothing to me. Nothing to me. So now we just need. We have UEQ. We have UEQ. What is MP? Mass flow rate and propellant. Propellant. Nothing the same with the burn rate. Yes, it should be. Let's just randomly write some stuff and hope for the best. 0.83 multiplied E. We don't know UE. Alright, I'm going back to solutions. They just subbed it in. Did I do a stupid? I did a stupid. Wrote the tip wrong. I wrote the tip wrong. Oh. I don't know why I crossed out the part that was correct. Okay. Yeah, they did unit conversions in it. Screw this. I'm not doing this. If I ever see an imperial unit, I don't even know. I'm gonna. There they are. Yeah, I'm just skipping this. I'm sorry. Too mad. I get it now. I'm just stupid. Actually, let me look at the UEQ thing. If UEQ MP is 1083 gallons per second. Oh. Here's a tip I need right now. Propellant mass flow rate is MP equals to MP is equals to turn rate multiplied by, what's my question on? Oh yeah. Turn rate multiplied by mixture density. The mixture ratio is unhinged. I just can't do. I don't know the unit to convert them. I don't even know what 1 gallon represents. 1,000 liters? No, right. Let me think that through. How many liters is a gallon? 3.785 liters. How would I ever memorize? Write it down, child. 1 gallon is 3.785 liters. And we have grams to cc. C is 1 milliliter. What? Oh, it's cubic centimeter. You fool. Oh my goodness. 1 cubic centimeter is the equivalent of 1 milliliter. How do I spell liter? Milliliter. There's 2 L's. Oh god. Well, there's 3 L's in there. And then milli has 2. I am relaxing on my bed right now. Or not relaxing on my bed. I'm putting my feet up on my bed. From my desk. Chair. Next we have grams. Grams is just 1,000. Divided by 1,000. Why is this value so large? So you want gallons and C cancel out. Convert this to liters. So this to liters. And you convert this to liters. 1 cubic centimeter 1 liter is 1 E equals to 0.001 liter. How do you spell liter? Oh. Oh. I don't know. It's both. Wonderful stuff. And then you just have thrust is equals to MP multiplied by UEQ. Now, once again, we would not have been able to do without the tip. That is one thing. So just be glad we have the tip. Oh. Anyway, let's get back into it. Very tired. So, no, I'm not gonna write out the equation. Oh, it's even the feet thing. As a feet to me. 1 foot, 0.305 meters. Oh, I've always used 0 point. Actually converts to no 2.5 convert location. No division. So next we have question 4. Unnitrogen liquids after do 3 and 4 tomorrow, like lecture 3. After I do 4 and 5 here. Question 4. Determine engine performance parameters. Well, technically it's break time right now. I should take a break because I'm supposed to take a 30-minute break, but I don't think I have time for that. I wanted to continue studying. Let us. I don't think I will take that break. An efficiency. No, we need a break. 30-minute break it is. I'm just gonna chill out here. And I don't know what to do. Have a snack, of course. Get some pain au chocolat. And yeah, that. And I need a drink. I have a drink. I have some croissants. That's for breakfast. Now, in general, we want to stand up and walk around, but I'll just stand up. That's good enough. I can't open this package. Goodness. Extrusion. Just social study break thing. Talking to myself instead. Chat then. Let's take set time. Hey Siri, set a 10-minute timer. much to talk about. Next. That's me trying to speak to picturing it so hard. Cringe. That someone is me. Crazy. What else can I do in the 7 minutes? I turn off my main screen. Surely help. Hop on Pokemon. Don't have to stream. Getting back into on the legend. I don't expect. I'll have to take. But no, it doesn't actually refresh your brain. I really want to look away. End this brain. That's just eat off the away. You know what? Two more things. Finish this bread. Toilet. And then then I'll end. Yeah, that was like a good idea. I'm crazy. Oh, that's a Diane scene. That's a pretty cool animation. Wise, like gems. Fancy gave gem to each of the six. Don't realize this. That's power gem. Fancy just earned guaranteed. I got three. Oh, 5 pack. Fairy type. Got 15 rock type. 5 Eve. Special mechanic. That's even mega roll. I'm gonna put like 9 right handed. Let's do it. Should we? I think just evolving. Uh, money out. On for 10 minutes. 24. Some berries to make thyroid. Boost. No! God, now it. No! Hell. Can you? I just kept going. Vaporeon and Jolteon. Vaporeon next. 98%. So let's name. Actually, let's keep this. I can walk him as much. I have Charizard as my. I have an Eevee I caught just to over and then transfer. Dragonite. Choose you. That's my last evolution. Need to power up some rock types and some fairy types. Let's do. Which rock type is Star? That's mad. Aggron. We don't. I'm out of Stardust. Holy shoot. Oh my god, it's because I upgraded Eevee like 100 times. Fancy. Not really cheap one. 8, 9, 10. You're not. Oh, I'm out of Stardust. How is that possible? Oh no. Oh no. I can't do any fairy type ones. I'm out of Stardust. I didn't even know that was possible. Tell me I have some Stardust. Select. Say. 1,000. At least 10,000, I think. Never run out. Tickets, please. Don't have any. Planning that stuff. I can't. Humaril might power up. Never had so little stuff. How much time do you have back to work? Catch 3 Pokemon. Come on. Uh, let's feed. I'm running as well. Landed. Yeah, you're belly making. It's like started. Raspberry. Running long berries. People have had that. Been in there for 55 days. Unless someone that it would be some Gym leaders are probably trapped in the by a headcanon. I'm not out of order. Why? Would you get a fairy type? Right, lucky Pokemon. I forget about lucky Pokemon. I have like yeah, I waste smarter. Shoot. Well, and get back to work. Alright, I'm back. Get straight into it. To open OPS. Well, already open. Tab into it. Have question 4 and 5 to do, and that's sleep. Determine engine performance parameters. So efficiency. Oh, I see it. Yes. And full time engine is thrust efficiency 0.4 HPR, which is mental. 4279 kilogram. Light speed 52 meters per second, and FS is specific thrust 1176 kilograms per determine ESFC and overall. Okay, first things first, you I'm going to find you. Look at the equations. See. Yeah. That's just. Turbojet engine. HPR, we saw that in the efficiency part. NT, find M. Oh no. Give me a HPR here. MF. I don't know, I think they're giving us a pretty big hint with HPR given. E to T. We don't have F. F is full air ratio. FS. Also, SFC. F. MF over. Ooh. Trust. F equals to MP. Wait a minute. I'm waiting. You're in your head. I'm just gonna assume take this one. What does the bar mean on? Oh, that's weighted averaging. Which we once again did not learn about. Newtons per kilograms per second. Grams. Oh, right, yeah. Seconds. Don't have F anyway. I know, we're not trying to find it. We have MO. Okay, now you have ambient velocity. And now we're gonna use HBR. Let's look at my notes. Right. Oh shoot. I wrote question 4 in my note. Also wrote fuel propellant efficiency propulsion efficiency is 2U over O over U. Propulsion power. That's not needed. I don't got it, man. I don't got it. Think, me, think. Another Pokemons. Be that Stardust, please. Sorry, I know I should be focusing. And I don't see an option. I don't know what to do. Let's substitute some things. Hope for the best. We have U0. In fact, have U0. Okay, if you look at the thrust-specific fuel consumption formula, we can work that out, I think. Pretty sure we can. Question 4. Nice. Oh my. Question 4. Common engine or parameters. Again, we write down UT 0.4 HPR 42798.4 kilojoules per kilogram. O equals to 152 meters per second. Fs 1176.8 newton. I'm sure it means per second. Means per second, means per second. UE. We'll find TSFC first. That's equal to Fs plus. I was wondering what A0 and M0 are. I'm an idiot. It's literally just velocity. 3 times velocity. Oh, sorry, it's just velocity. So yeah. Efficiency thrust HPR. Wonderful. We can find that. SFC is approximately Fs, which is given 1176.8 second. Times A0, M0 is U0, because we know that Mach number equals U0 divided by A0. A0 over, that's M0 A0 times 142, that's meters per second as well. My pen is failing me today. And we have Newton at 0. or E to 2, sorry. But for HPR, which has a big number, we have meters per second divided by kilojoules per kilogram. Now, my brain's saying newtons, but probably newton seconds. Meter second. Joule equals to Newton meters. Okay, my brain was right. Write that on notes. Square bracket. 1 Newton is 1000 Newton. Kilogram meter second squared. So kilogram is per second. Meter squared per second squared. That'd be squared gram. That K on the side. And so those two would be meter squared per second squared. So total specific fuel consumption. That's a weird one. Well, as long as I have it in the correct units, it should be fine. Approximately 0.049 K meters per second divided by squared per second squared. Approximately multiplied by 1000. 43 point per second multiplied second squared approximately meter second. Now I'm gonna check the answer. Oh no, it gives 0.1557 kilograms per Newton hour. Kilograms per Newton hour. Kilograms per Newton hour. Thirteen kilograms hour. Get kilograms divided by kilograms. What? Who? What? Newtons times hours? I hate this so much. Why are you using some? Yeah, it's probably. I do this. Second hour. 60. 600. 600. Cancel. S should be on squared. Uh, second. Should be seconds over. Seconds. I did something. Oh. M negative. Why am I multiplying? I want such a large math. By that. I did in fact get the multiple. Wait, no. Oh, right. Yeah, I can. Answer is correct. But I don't get it, because how can you make seconds with hour? I'm correct. No. To seconds per meter. Oh, my stomach. I think I'm having a stomach ache. I got the answer, let's go. I don't care. I have the units and everything. It's correct. How teachers think, but, you know. I don't care. I'm pretty sure I'm correct. These power-up quests ruined my money. My starters don't. I'm looking at my phone. Sure, after I attach this Paris. Okay, next up we have TSFC. SFC. Let's flow rate of the fuel over thrust. We also have FS rather. Fs is F over MO. So we smash these together. We have F on both sides. F is MF over TSFC. Fs MF over TSFC times MO. Let me make sure it's correct. Yeah. Now, what do we have here? We have nothing. Negative items. Let's move TSFC over. We have SFC divided by FS, MF over MO, and is that fuel air ratio? I believe it's fuel air ratio. Please, throw me a bone. MF over MO is fuel air ratio. Because I'm a fucking genius. Don't even know. You don't even know. And with fuel air ratio. Yeah, no. SFC? Oh. Oh, my answer's gonna be. I'm using actual units. God. Such an annoyance. You have to be the smart one. God. Well, if they just change that to kilograms per Newton second, I'd be fine. I must use the tool. I'm having a bad stomach. Don't worry, guys. I practiced German in the toilet. Yeah. Oh yeah. Nice. Alright, let me get back in the flow of things. Where was I? Yes, FC. Yep, we found that. We found F. 42. 4.3249 multiplied by SM negative 1 divided by 11768. Yeah, see, I can just multiply by that and I'll get like a ratio. And whatever the hell that ratio up. I got 0.05. Right, which makes sense. If you multiply by 100, percentage right there. 5.05%. Horribly small. Don't know. We have F now, so we move on. I don't know if F is a percentage or not. Where ratio? It is not a percentage. It's a ratio. 40 pence. Now we want to find UE and eta E and eta overall. So we have FS, we have F, we have F for turbojet, F the mass F1 plus F. What? Alright, we have UO. We don't have MO. FS, turbofan. Ah, here we go. Can we find F? Find F. Find F. What a turbojet? No. Variables. Yes, 1 plus F. NP though. NP. Oh. Okay. My second option is to change the subject formula. MOEF times 0. We have U0. equate. Wait a minute. Waiting. I think I got some. I got some. E minus U0 is Fs, isn't it? It is. These equations. Yeah. Isn't true. It is meters per second. Maybe? I'm looking for UO. Is that right? Multiplication. Fs is 7 seconds per. Damn you, vile villain. Do this again. Nice. That is expected. I'm not trying to do this in my head. I know the right now. 8.8. What do you guys get? 1329. Let's freaking go! Let's go! Oh, okay. Okay, we got UO, we got UE, we don't have MO. How do we find MO? Very easy actually. Wow, I am seeing a whole different world right now. Maybe I am chosen one. So, propulsion efficiency to F, then UO divided by 1 plus F MO squared over 2 minus MO squared over 2. So, look what we found. We had the F already. Genius! What we need to do is take MO out of both sides of the equation. Take it out, them all into brackets. We have NP F over MO. You know where this is going? You know where this is going? And then you have it multiply U0 divided by inside of a bracket 1 plus f m f times squared over 2 minus all in square brackets O squared over 2 2 so fs is as we calculate 11768 meters per second multiplied by a second divided by u0, which is second, we just calculated at no u0 second divided by 1 plus f. F is a fuel ratio. This value is a ratio very small plus 508. Actually, no, correct. Divided by UE squared. Calculated 138 squared minus U0 2 squared over. Come to the conclusion that it's going to end in meters per second. No, it should have. And you multiply by 1. Typing in the calculator. Ain't no way I'm doing this. Facts. One nine five ellipsis, approximately 5%. I think it's not the answer. How they did it. I'm not gonna. CF. Oh. It's given. She. See what I'm looking. Here we got this differently. I don't know why I did it. Literally this. And then my one of the professors was talking about it, and oh yeah, you need newtons. I was. Maybe that's just how it's denoted. Tell you that it's cost efficient, which makes a lot of sense about it. Yeah, it's literally meters per. Okay, let's do this one. That's what I did. Except, I don't know, it just disappeared. Like they're just assuming that's a very small value. I guess. I missed a 2, I think. I lost out on a 2. 7 2. It's very similar, it's just this effort. I would have gotten it correct, I believe. So I did calculate the F unlike them. So let me just finish the question. I'm just too smart. They're stupid. I don't, I'm very proud of myself as smart. FOMO. Have N overall simple. Yeah, right there. Engine. I don't see either. uh, it's it's a not easy. No, I got very close. I did. 7. Yeah, 7. Which I'd say this is correct. Like, I even did it back then. OBS go. I will get through this. Question 5. How we doing? Question 5. Herman? Question. Um, then we have an M. Mark numbers. Mark. Initial mark number 8 at kilometers. And A0. fuel value are 4280 kilograms. Mass flow rate 5 seconds. Mass of F equals newtons. Mass flow fuel mass flow rate. Hopefully this is just a plug in. Oh my goodness. You want me to find one? 8 things. Gonna be easy. Okay, it should be easy. You can easily determine F. F. S. Should be easy. A turbojet engine. I feel like I didn't finish some animes. I just drew on my monitor. On a mama. Okay. Fuel cost. Sorry. Fuel air ratio. So from that, we already know that it's M dot F M O. That's 0.5 second. T5. And that's a small value. Value 5.58 shares. FS Pacific Thrust. That is sure I don't get F over M dot O rather. 50k divided by kilograms meters second squared divided by kilograms per second. That would 2,000 is 1 kilo thousand Earths. Grams cancel out is second. Yes, of course. And write this. You have to remember that it's seconds. See them. I'm wrong. Yeah, because it's FS. Gotta remember that. Oh. There we go. None. That's correct. I mean, not the options. Next time we have u. See if that is calculated. So we have F, S. A lot of things. E. Have MO and UOs. We can calculate. Arrows. Jet. Honestly, I think I might do okay in O. Then you want to manipulate this F over M O equals 2 M times A, I believe. Nine seconds. It has to be. F over MO. Done that as FS. Which we know FS is that's left is a lot. SFC. Oh, this is just to get us to understand the equation. S MF. We have MF. F over F 5 plus 50 K per seconds. 0.65 divided times 10 is 5. I don't know what Newton. That's right. Oh, they just wrote kilograms per Newton seconds. Something I can. Or I could. Yeah, it's TSFC and FC. So technically, I can write it just in terms. So cool. SFC. Move on to E. How bad my handwriting is. Engine power out. That's part that is 2 1 plus F M. Oh, looking at. Oh, you're looking at the wrong. Movements. Movements. All divide F H R. I've gotten used to propulsion and whatever my title is. Rush principle. I'm very happy about that. I will make this, hopefully be able to use it. So there's a high chance I get at least 50%. That's 1 plus F was F 0.589 divided by MO, which is 5 kilograms per supplied moment is 507. And that minus MO 45. Gonna really try to chill out, sleep out. Squared L. Divided it. Divided it. Divide it by MF. 3. Yeah, no, that's wrong. Don't divide it by anything. Motion efficient. Oh, sorry, this is just engine power output. Plus 0.589 and bracket 5 kids times 0 squared over 2 bracket minus 5 bracket times 39 squared over 2. Damn. I have to work out the units because I've never done this before. We have MO, which is kilograms per second times velocity per second meters squared per second squared. Which is equals to kilograms per second. Kilograms squared per second. That watts. I don't know if that's watts or not. Well, PE isn't in the bonus instructions. Let's just work this out first. Get thermal efficiency, motion efficiency, and the gain. Oh wait, it's Newton's. That's not Newton meters per second. Per second, yeah. That sounds about right, because it's joules per second. That's power output. That's watts. Let's go. Other watts. Let's see if that's correct then. And T equals 2. Massive number. divided by MFHPR. $2.65 times HPR 80. A lot of math. Kilograms per second times joules is Newton meter. Right? Right? Joules is meters, yeah. And 1 Newton meter is kilogram meter squared. Second. And yeah, that is exactly what we're looking for. No units, I forgot. The ratio. But it is times 1,000 because of kg. Which size are it? And we get 0.56, an answer that we're expecting. See. No, this is not. Is my P is wrong? Can we check the math on that? F isn't wrong. Try that again. Plus F, that's 0.589 times 45, that's MO second. Squared over 2. Must have missed a square. Oh, my UE is wrong. Oh, because it's wrong. I think is correct. Yes. Oh, I only checked. No, that's not true. I see. I use this. And I should have been. I'm not sure. Doesn't mention any pressures, but I don't know. Oh, you can't feel. I use this for the calculation. Well, I've done all the steps correctly except for this new E part. They miraculously used. Assume the pressure term is as in they use the general form of thrust equation. And then they assume that the pressure term cut off this. They were left with. When you're assuming the pressure term is relatively not using this. How much does that change the efficiency? I got 5, 6, 0.33. No, just change it. I guess we have the F value, which is 0.589, which is pretty large. I'll keep that in mind. I'll do it again. And, I would have followed the rest. Fine, let's see. F and 0, we have those. That's fine. And NO is just multiplication and none. That is it. I'm not fit for topics again. Brush principle. I didn't actually ask to use materials. Professor Chinlin. Materials. And presentation as well. So, yeah, useful because I helped me understand it well. But yeah, next we'll be doing basic analysis of a gas turbine and then gas turbine engine components. Like 6 as well. I might do 5 and 6 together, and then I don't know. I'll see how it goes. But today I'll for sure just be finishing number 3. Or I'll probably do 5 and 6. 7. And then I'll do overall practice. 7 is probably low speed area. I won't get it, so it's fine. Yeah. Thank you very much for watching, and I'll see you guys next time, hopefully. Bye bye.